Here's a Pearson correlation example. Remember that a correlation of negative 0.8 is just as strong as a correlation of positive 0.8. The sign indicates the direction of the relationship, not its magnitude. So for example, if I had a correlation of negative 0.9 and a correlation of positive 0.3, the correlation of negative 0.9 would be stronger because you only look at the number to determine the strength. Again, the positive and negative just tell you the direction, not the magnitude or how strong a correlation is. Remember that N refers to the number of pairs of scores. So correlation equations that are new for this chapter, S sub P is sum of products is equal to summation of xy minus summation of x times summation of y over N. And then the correlation is equal to sum of products over the square root of sum of squares for x and sum of squares for y. Let's look at an example. Given the following data of x scores and y scores. First, you will set up 3 new columns, one for x squared, one for y squared, and one for xy. You will compute these columns, x squared based off all the x values, y squared off all the y values, and xy by multiplying the x and y together. You will sum up each column. These numbers will all be needed to compute the Pearson correlation. So pause the video while you do the math and then check your numbers with mine. Step 2, realize there are 5 numbers in each column of x and y, so n equals 5. Sum of squares, we're going back to our original equations we used for t-test. Sum of squares is equal to summation of x squared minus summation of x squared over n. So put in the numbers that you found from your table and solve the sum of squares for x. You should get 10. Again, pause the video while you do all these calculations and then check your work. Sum of squares for y, you do the exact same calculation, but you use the y column of scores. Sum of products, this is a new equation. You use the summation of xy, which is 22, minus summation of x, which was 10, times the summation of y, which was 20, all over n, which is 5. So again, you do the fraction first, and then you subtract from 22 at the end, and you get a negative 18 for these sum of products. From the answers above, you can compute your Pearson correlation. You put in negative 18 for the sum of products. You put in 10 and 40 for your sum of squares for x and y. You should come up with a correlation of negative 0.9. This means that the line is falling from left to right, and the dots are very close to a line of best fit. They fit it almost perfectly, not quite, but almost. So 0.9, very, very good correlation. Negative just means it's falling.